Well, this is really expensive, so I probably need 2 of those. Whoa, who are you? I'm you, from the future. I've come to teach you how to do astrophotography. I can see you were about to buy a bunch of stuff that you don't know how to use, and much of it you probably don't even need. I've come to tell you the top 5 things that I wish someone told me when I was beginning my astrophotography journey. What? That's crazy. No, I need this stuff. I already tried taking some photos of space and they didn't look anything like the photos the YouTube guys show me. Mine came out completely black, and the one photo of the Orion Nebula that I took actually didn't have any color at all. It was just all grayscale. So it must be something wrong with my equipment. No, you're thinking like a terrestrial photographer. Taking photos of space is totally different than taking photos of people. To take a traditional photograph, you simply point your camera at the target, press the button, and since there's usually plenty of light, your photo will show up on the back of the camera's LCD screen nice and bright. But celestial objects are really faint. The data is there, but you're going to need to do some work at the computer to make it visible. Now, I tried that. I brought my photo into Lightroom and boosted the exposure almost all the way up. And I was able to see like a little bit of something in there, but it looked horrible. Well, that brings me to point number 2. Lightroom is a great tool, but you're probably going to want something far more powerful for astrophotography. Photoshop is a great place to start, and it will allow you to stretch your images. How can I explain stretching? Think of it as boosting the exposure, but in such a way that it won't blow everything out. You'll need to forget about your normal compositing and editing routines. Editing astrophotos requires a totally different set of techniques. I'll be creating a video specifically on editing in the future, which reminds me, don't forget to like, comment, click the bell, and subscribe. All forms of user interaction help the channel. Who are you talking to? Well, I took a photo last night. Maybe you could show me how to edit it right now. A photo? A single exposure? Okay, you can do that, but it's likely to come out with a fair amount of static or noise in the image. It looks like your traditional photography roots are complicating your astro ambitions. Let's say that I want to take your picture. Now, I'm going to take several shots just in case you blink or you have a funny look on your face. But at the end of the day, I'll just pick the best one and toss out the rest. I think we really captured you in this one. You look pretty sharp. See, you only needed one image to be good. Deep space photos, however, usually aren't comprised of a single image. They look best when you take a whole bunch of images and then use a special computer program to stack them together. When you do this, the final image is brighter and it also reduces the noise. I think I've heard about this. So do I just use the auto alignment feature that's built into Photoshop for that? No, I tried that. And it totally doesn't work. I ended up wasting a lot of time chasing that one and finally realized that there are specialized tools for astrophotography that do this far more efficiently. The one that I use is called Deep Sky Stacker. Now, I use this primarily because it's free and I'm cheap. But I see the best results coming out of an all-in-one stacking and editing tool called PixInsight. That application is not free, and you need a double doctorate in physics and computer science to be able to use it. Now, of course, I jest, but it does have a steep learning curve. So if you're just getting into this, I recommend that you keep it simple. I'll be creating a video on Deep Sky Stacker soon. I'm going to subscribe right now. Deep Sky Stacker isn't really self-explanatory, and it really intimidated me when I first started learning it, but once you get a few basic concepts down, it's actually really easy to use. So what kind of equipment do you recommend that I get? The methods and tools you're going to use to photograph space vary greatly depending on the subject that you want to capture. I'll be making another video that dives into this topic in a little bit more detail, but suffice it to say, you don't really need anything super fancy. For example, you can take pretty great wide-angle shots of constellations and even the Milky Way using nothing but a cell phone. This is also a great place to get some easy photos to start practicing your Photoshop stretching skills with. When you feel that you've gotten all you can out of that, then upgrade to a DSLR like this one. They're great for wide-angle landscape shots, but whichever camera you use, make sure that you prop it up on a good tripod so that it doesn't move while you're taking the shot. Any little movement will result in a blurry star trail. I also recommend using the timer that's built into your camera. Pressing the shutter release button will jiggle the camera around, and the timer will give the camera time to settle before it actually starts taking the picture. Adding a zoom lens or even a small telescope, you can get more distant targets, but under magnification you're also going to need to add something to counteract Earth's rotation. A portable star tracker will work perfectly. Now, you're going to max out the capabilities of your DSLR if you want to start taking pictures of deep space objects like emission nebulas. There's a filter that's built into the camera right in front of your sensor, and it's designed to block out mostly infrared light, and that's the kind of light that is coming from a lot of these targets. So it's going to make them really difficult to capture with a DSLR. You can astro-modify your camera to remove that filter, but I decided just to get a cooled, dedicated astronomy camera. The filter in those comes removed by the factory, and the cooling helps reduce noise in your image. If you want to image deep space objects or planets, then you can use a telescope with a long focal length, and this brings me to my fifth and final piece of advice. You should really start wide. I made the mistake of using the telescope that I already had. It was an 8-inch Schmidt Cassegrain telescope with a focal length of 2032 millimeters. What does that mean, focal length? I know that that's a lot of numbers and fancy speak, but what it really means is that it zoomed in really far. At that magnification, even the slightest amount of movement will result in a blurry image. And not only that, at f10 it required a really long exposures in order to be able to capture enough light to make a usable image. I was trying to use 30-second and 1-minute exposures of untracked super faint stuff, and it just wasn't working. Overcoming these challenges meant getting a solid equatorial mount, using light pollution filters, using a tracking camera, and hooking everything up to a computer that kept all of the parts working together. And that's a lot of stuff for a beginner to soak in. But don't worry, I'll be making videos about how to do all of those things as well. But if you want to start with a fast telescope with a wide field of view, your tracking won't be as important, and you'll be able to get away without a lot of that other stuff. Oh, and one more bonus thing, when it's time to start imaging planets, that doesn't use photos at all. You actually do that by shooting video of the planet and then using a special program to convert the video frames into a still image. It's the subject of a whole nother video altogether. The temporal anomaly is pulling me back, but before I go, I have to give you next week's lottery numbers. The numbers are 37, 42... couldn't you have led with the lottery numbers? Jeez.